Hey, this is Sanyam Bhutani and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I'm privileged to be interviewing one of the wise and senior Kagglers who have retired from their life and working on Kaggle. Just kidding. It's my privilege to be interviewing Dr. Christof Henkel on this show. We talk a lot about his previous assumed life of having worked as a construction worker. You might be surprised to watch the video. In case you're tuning in from the audio, please go to YouTube and check out the video stream. Jokes aside, in this interview, we talk a lot about Christof's Kaggle experience, how he got interested in Kaggle, his Kaggle journey, his Kaggle pipeline, and his recent second position solution to Google's Quest competition. Again, you can find the links to their write-up and the competition in the description of this podcast. We also discuss Christof's new job at Rapids, where he's just joined as a senior deep learning data scientist. Christof shares many advices around approaching Kaggle competition and deep learning, which is his area of known expertise. So I'm really excited to be releasing this interview. Quick reminder to the audience, please remember to enable the subtitle. If you're a non-native English speaker, it'll help your watching experience on YouTube. Without further ado, here's my interview with Christof Henkel, all about Kaggle, data science, and Google Quest Q&A labeling's second position solution. Please enjoy the show. Hello, everyone. I'm on the call with Dr. Christof Henkel. Christof, thank you so much for joining me on the podcast.
Yeah. Hi. Very, very glad to be here.
Likewise. I'm not sure if this is Christof or you're his son. Can you confirm or deny? Because I've seen Christof's image on Kaggle.
Yeah, I'm the real Christof. I think it should be quite obvious that I'm not like over 70 years old.
I think you're lying. You're breaking a lot of fans' hearts.
Yeah, and I know that I even fooled some of my fellow Kagglers, which they were really surprised to see how I look like in reality, because like there's a lot of people who think that I'm like a very old man who, I don't know, found his love to data science and now in his retirement spends his time on Kaggle, but that's not true. And if you look in the discussion posts of mine, I heavily use emojis, which I think is quite unlikely for someone of this age. But
maybe using a deep fake to overlay a video, no one will ever know.
Yeah.
Okay. Jokes apart, I want to talk about your background first. You hold a PhD in math and have a traditional academic background. How did data science start to come into the picture for you? Was it a part of your research days?
Not really. So my topic was about modeling of stochastic processes with applications to financial markets. But during the PhD, I made the first step towards data science, I would say, by using R to do the simulations of my thesis. So there I, let's say, discovered my love for programming and my love for modeling and simulation. So that was the first important step, I would say.
Okay. And you followed the traditional academic research path. What made you pick math as a career and take up research domain?
Yeah, that's quite funny because I started to study math rather as a coincidence. So during my civil service, I just wanted to enroll in any subject which was easy to enroll, just to be at university and to have time to orientate what I want to study, because I didn't know at this point. So I enrolled in math because there was no restrictions and it was quite easy just to start with this.
Okay.
Um,
So you found math easy?
no. It was the enrollment process was easy. So there was no restrictions, no tests to get on board and so on. So I just took math, because I wanted to be part of the university system and then see what I want to study. But then I took my first semester and it went quite well, and then I also had a lot of fun, so I stick with that. And the funny thing is, I also never imagined to do a PhD, and only in the very last year where I did the master thesis, I discovered that like this self-driven work where you work on something for yourself and you are independent and just write your own thing and research in your own area is really, really a nice thing, and I really love to do that. So so that's at the very end of my studies. I then just realized, okay, a PhD could be fun, and then so that's
your
how it
Kaggle
all...
profile does look that of a person who's completed a PhD.
Okay.
No, okay, no more jokes, I promise. But how did you find your traditional background helpful, your background in math helpful once you got started in your data science journey?
Helpful, yes. I would say math has different fields. So I think for machine learning and deep learning more specifically, I think linear algebra and optimization theory helps the most. And my focus was on probability theory. But still, you get like the basics of linear algebra during your studies. And also I think machine learning and deep learning specifically has also a lot to do with probability and statistics. So it's helpful. And I must admit, one very helpful thing is probably the confidence to read research papers. So I think to be very good at competitions, you also need to keep up with state-of-the-art results and to read like most recent research papers. And during the PhD, you gain a lot of confidence in doing so. So reading new stuff, having, complex formulas to understand and this kind of stuff. And I can really imagine that this is quite difficult for beginners, not to do technically, but rather from a confident point of view.
So is it true for your case that you read a math paper and around your head the code starts to pop out? Are you at that expertise now?
That's a bit extreme, but I know how to code the things I read.
Okay. And when did you find your passion for data science? Was it through Kaggle or earlier than that?
No, it was through Kaggle, of course.
Okay.
So, yeah.
So what made you sign up for your first competition on Kaggle? How did you get started on Kaggle?
That was right, let's say, in the last few months of my PhD. And I was finished with writing everything and just taking care of the bureaucratic stuff. So preparing for my defense and preparing a final presentation and this kind of things. And finally, I had a lot of free time. So I used to work like 30 hours a week and do a PhD on the side. Yeah, I started to watch YouTube videos around deep learning because it was quite famous at this point of time. Yeah, and by this I somehow came across Kaggle, and I directly jumped into my first competition,
Okay.
which was quite challenging already. Yeah, and since then I'm hooked on Kaggle.
How was your first competition experience like?
It was really tough. So I directly jumped into a real one, so to say. So no playground competition. I just like directly jumped into deep learning for speech recognition. And I had no clue about audio. I had no clue about deep learning. I had no clue about TensorFlow. And what's quite funny, I never used Python before. So, so a lot of new things to learn. So I learned TensorFlow together with Python, together with deep learning approaches and everything that comes with it. And of course, I don't know, objectively, my result was not too great. After 2 months of very hard work, I was like, play 300 out of 1,000 something.
Okay.
But I learned an immense valuable things there. Yeah, and since then I'm continued competing and continued to become better and better and to work on myself to improve.
That made you accept the challenge of Kaggle and you took on the challenge full time.
Yeah.
Did you expect it to be an easy experience, your first competition, or
no, it's not easy at all. I don't know anyone who says that Kaggle is an easy experience. Because there's like, even those competitions which seem easy, they sometimes have either some twist which makes them hard, or they are so easy that it's easy for everybody, and it's hard to find an edge against other competitors, which makes them hard. So there's no such things as easy competitions, I would say.
How do you now balance the time spent on competitions with life and work? Now that it's confirmed you're not a retired construction worker.
Between Kaggle and work, I guess we will talk about that later anyway, because I just joined the Rapids team, and there you have a very high synergy of both. But private life, I think it's anyways important to every now and then, I don't know, make a step back. So to have some time, think about problems, and to let's say that ideas, just are created in your head that might take a little bit of time. So a lot of really interesting things are like things that pop into your head while showering or something similar. And the same is for like, if you go for a run, or you have some day off when you go skiing or something. I think that's really important, to have less pressure during the competitions, and to be like more at ease with yourself, and to have a fresh mind to think of new things.
I had a very interesting experience. I remember Jiba mentioned during his interview that sometimes during your sleep you get ideas, and I told the same thing to SRK. I'm fortunate enough to sit right next to him at office, and he said, no, maybe they don't work most of the times, those ideas.
Yeah, the one in sleep don't work, but the one from the shower, they are really good, because at least for myself. But okay.
How do you think the things that you've learned on Kaggle has impacted your professional life?
I think you learn a lot of self-discipline, I would say, and problem solving, of course, but also a lot of strategy and a lot of how to deal with pressure, I would say. So that's all aspects that are also important for my professional life.
Also good meme posting skills.
Also
That's important.
That's actually true. I think it's like the social interaction on the Kaggle platform, so posting discussions, answering questions, discussing different concepts. I think that's really important also in your professional life. So to explain complex things in an easy manner, so even beginners understand it, that's quite an important skill, I would say. And a lot of people in the data science community lack the skills and complain that it's hard to explain their ideas to management or something similar. So I think it's really, really important skill to explain complex ideas in a simple way.
Okay. Now, I want to talk more about your approaches to competition, and I'd like to use your recent 2 gold finishes. But before that, what sort of competitions do you usually enter? What competitions do you enjoy working on?
So I try to do competitions that are very different to the ones I've done before. So to enlarge my skill set and enlarge my scope. So I started with audio, but then I did NLP, computer vision. I really enjoy hybrid competitions. For example, there was one about Avito product demand prediction, which was from the architectures quite similar to the pets adoption prediction. And in both you have some profile, let's say, if it's a product profile or a pet profile, and you have various images, you have text, you have tabular features, and it's really interesting to combine all these different aspects and to build. So I guess I'm known for building my deep learning models. And I love to build like deep learning models that have different components. So you have one component which handles text, you have one component which handles images, and then you have to somehow integrate all the different aspects. And that's quite challenging and makes a lot of fun, in my opinion, because you have a lot of freedom in what you do. And you can try a lot of cool things, I would say.
This is also a question from the AMA. What number 1 mistake do you think most people make while training deep neural networks? One mistake or one thing that they miss?
I think neural networks, there are like a lot of small things that you can do, not necessarily wrong, but not optimal, like pre-processing, for example. So most people just standard scale their variables, which is fine as a starting point, but not optimal for most. The same is with handling NAs or clipping values or all this kind of stuff. So there's a lot of small things that you could do better, I would say. And it's really hard to do better because there are not much education around that. So you wouldn't find much tutorials how to build a very good neural network for tabular data. That's unfortunate, but good for me, I would say, because that gives me a little edge in competitions. What else? I think often people think too big in terms of neural networks. So instead of starting small and then trying to grow, they start with something fancy and big, and then you have a lot of problems that comes with size of the network, I would say.
Okay. Now, coming back to Kaggle, what are your first go-to steps when working on a problem? And do you again start with small iterations, or do you have pre-written code that you bring into the competition?
Both. So the first thing is I built a very fast and simple baseline. So the fastest, the better. Just to have the full pipeline already, from pre-processing, over training, over post-processing, if necessary, until submission. And then the next step is to set up a solid cross-validation scheme. So I think that's the most important thing for a Kaggle competition, is to have a valid local cross-validation, which somehow matches your the leaderboard, because otherwise, how can you optimize something if you cannot relate to leaderboard, right? So that's the most important step, and I emphasize this one so much that for some competitions, I spend a huge amount of time until I get the cross-validation right.
Okay.
Because in my opinion, it doesn't make sense to optimize something that won't be reflected on leaderboard. So for example, one of the recent 2 competitions, so the TensorFlow 2.0 question answering, I spent, I don't know, weeks to reconcile the competition matrix, because the sponsors were quite intransparent about it, and everybody had and there was even a bug in the metric. So I spent like, I don't know, 2 or 3 weeks to figure it out. And then I finally found a bug and they changed the metric afterwards. So I needed to start again. So sometimes it takes for ages to just get a solid cross-validation scheme. Sometimes it's quite simple. Sometimes it's right from the beginning, but sometimes it can be really hard. And then I spend a lot of time on this. So that's my first step. And as soon as you have some solid cross-validation scheme you can use, then I start iterating ideas. And for this, I like to scale down, I don't know, the whole architectures and models. So I use a very simple model and just iterate through whatever I can find, basically. And just at let's say the second half of the competition, I start with slower, larger things.
Okay. For the beginners who have absolutely no idea of how to create a good cross-validation framework, who just copy 4 most of the times, what best advice do you have? How do they learn better ideas about cross-validations?
That's difficult, because it really depends from competition to competition. So normally there is, most of the time, there's minimum one discussion post about cross-validation and cross-validation leadership, everything that's posted in this discussion post. And also, try to, if you have a big gap between your local cross-validation and the leaderboard, try to understand where this gap comes from. So normally you have some kind of leakage between your train and validation set. So can be something simple, like having I don't know, if some competition about users or something, having same users in your training and validation set can create some leakage, which can be quite obvious, I would say. But sometimes it's more difficult. For example, when I was in an image competition where you had very similar images, but not exactly the same. Okay. And it was really hard to find the similar images, and then because you don't want to have similar and to put them in one set or the other.
So we're all fans of your awesome results from competitions. Talking about the recent 2 wins, Quest and QA, did you find this problem to be easy and relevant to your previous competitions? I know you just entered the Quest competition during the last 2 weeks, which is unheard of for someone finishing in their second position.
Yeah. Okay. I did I did some competitions previously related to NLP, where I used, I did 3 already before TensorFlow Q&A. The first 2 were still pre-transformer time, where there was like LSTM, the state of the art. And then the one before was like from Jigsaw, you need to identify bias and comments and so on. There I already used transformers, so that's what was a big advantage. And I already used the Hugging Face repository, which helps a lot. And I made already some mistakes, which I then, let's say, could learn from. So that gave me a head start. But I've never done anything related to question answering and to text span prediction, because for the TensorFlow one, you needed to predict an answer span, so really find the correct start and end token in a Wikipedia article. So that was something new for me. Also, how to use huge inputs. So normally the transformers, you have like a maximum input of a specific size, which is way smaller than a whole Wikipedia article you need to analyze. And then you need to come up with some clever way in going through the whole article. It was also something interesting to learn. Yeah, and then I thought, naively as I am, that it's a piece of cake to just enter the question answering, the Google Quest competition afterwards, because you also have question and answers, you also use transformers. So
and
it's
you
like,
were bored.
yeah, and it's like piece of cake. But at the end, it was not. It was like really, really different. And yeah, I needed to learn a lot of new things. I haven't used the Spearman rank metric before. That created some interesting things. There was a lot about post-processing, which was quite different. What's also very different was the size of the data. So for the TensorFlow one, you had like 100,000 of documents. And you trained for, I don't know, one model trained for 30 to 40 hours. And the Google Quest, you had like 6,000, which creates, yeah, quite different problems, because you overfit immediately and you have a lot of other things to deal with. Okay. So yeah, you can always reuse your pipeline and reuse the things you've learned, but there's always something new, even if it seems like it's the same.
So how did your approach vary for the Quest one? Because you had 2 weeks to the final deadline of the competition, and yet your team finished second in the position. Amazing result, because I'm sure it was a team effort, but if you could tell more about the approach.
Yeah, yeah. Of course, it was a huge team effort, and we were really lucky with the team. And I knew in picking the respective people what their strengths are, and I really looked for a team which has all the necessary skills. And I was
How did you convince Philip and Dimitri to not use the team name Zoo?
It was a simple poll. So we made a simple vote.
Conspiracy?
No, we did a simple vote. We had like 10 amazing team names suggested, and then this one won by simple
okay.
simple poll. Yeah. Yeah, I think the main thing that differs from other competitions, if you only have like this limited amount of time, is you need to be very efficient and really, let's say, trust that your team members will do their part. So for example, Philip and Dimitri concentrated on the post-processing, and I didn't even touch it. So I concentrated on model architectures. So you need to trust your teammates. That's quite important. And you also don't have time to try too fancy things, I would say. So there was, and that's quite interesting story, because there was a paper by Facebook Research, and they published a pre-trained model, which is called BART. And I had it on my radar. So I even posted it in the external data thread, because I wanted to have the option to use it. But then I didn't have time to implement it, because it was not ready to be used by the standard Hugging Face library format. So I went on with simpler things that are easier to implement. But if I would have had more time, I of course would have checked it out, because it was like a promising architecture, and I didn't. Yeah, so it was quite funny, because the first team saw a post I made in the external data thread, where I gave a link to a paper from Facebook. Yeah, and they implemented the model, and it was their best performing model, which is quite funny because if I hadn't posted this link, they wouldn't have had it on their radar. And yeah, I didn't have time to implement it for our team, so that was quite unlucky, I would say. And if we have had more time and not only the 2 weeks, I definitely would have checked this one out too. So you have not time to try two things that are too new. You rather concentrate on things that you confident that will work, and you're always you also think about what's the most promising things you can implement in short time. So not what are the promising things in generally, but what are the ones you can also basically implement in a day or two to have it done within the given time. So that was different to other competitions. In other competitions, I take a lot of time in reading domain-specific papers, reading the background, check out Git repositories related to the domain and so on. And then in this competition, we didn't have the time for that kind of stuff.
So there's this prevailing sentiment that you need a huge cluster of GPUs to win a gold winning solution. Can you speak to that sentiment and share your hardware setup for the previous two competitions?
Yeah, so in generally, I don't think you need a lot of compute power if you're not competing in like computer vision competitions and in like this huge NLP competitions like the TensorFlow one. But on the other hand, I might be a little bit biased what means huge. Because I have a desktop PC with 3 graphics cards, 3 GTX 1080 Ti from NVIDIA. So yeah,
from
for
your
me,
construction savings from your previous life.
For me, it's not that much, but it might seem much for other Kagglers, I would say. But it's not that I have a DGX or something of like this size. In the previous one, I also used a little bit of AWS compute power to just squeeze in more experiments in these 2 weeks. Because otherwise it would have been difficult. But it's rather for doing this stuff parallel and not faster. It's rather for doing the stuff in parallel, especially when training a k-fold schema where you have like 5 folds which are identical and you just want to run stuff. But for my normal experiments, I normally use my desktop, and that works out quite well.
Okay.
Yeah. So you interviewed the zoo, and I really enjoyed this interview too. And I fully agree with Dot's opinion that having restricted hardware, enables you or forces you to think about creative solutions that are simple, and also to think about implementing in an efficient way computationally, which is also a skill that is important from my point of view. And it also forces you to think about efficient iterations through your experiments. So, for example, use very small models in the beginning and so on. That all starts basically by having hardware restrictions and by not having unlimited computational resources.
Okay.
So I think it strengthens your skill set in doing more efficient models.
Okay. Now, I'd like to discuss about your gold-winning second position team solution. If you could give us a very high-level overview, I'll definitely have the write-up linked in the description for those who want to check out the complete detailed write-up. But if you could discuss the very high-level overview of it.
Yeah. So for those who are not aware, the competition in 1 or 2 sentences was about multi-classification. So you had like a Stack Exchange post, questions, and a related answer, and you needed to binary classify, or you had like not classification per se, but rather regression between 30 different targets. Some were rather question related, something like how good the question is written, how good the answer is written, how good the answer matches to the questions, what type the question is of. Is it an instruction or is it not a question at all? So there was one target question is not really a question. And you had to use NLP methods to analyze the text and to predict those 30 targets. And right from the beginning, it was clear to us that transformers will perform best. So we based our solution on an ensemble of transformer models. At the end, we had 5 different ones with slightly different architectural tweaks, but quite similar. And we used different pre-trained backbones, which we then tweaked a little bit, changed the architecture a little bit, and then used, let's say, specific post-processing in making the predictions closer to what's a good performing target. So the metric was really about the ranks of your predictions. So it was like Spearman rank correlation with a specific tweak on ties. So if you predict the same prediction, that it's scored differently than if you have like really close but not the same predictions. And you can improve the metric a lot by handling those ties correctly. So I would say our solution is like twofold. One thing is the modeling itself, and one thing is the post-processing. And we were really aware that there's a huge shake-up potential, which you also could see after the competitions. So there were a lot of teams moving up and down, and we stayed quite stable. But we also spend a lot of time in figuring out a way that's robust on the private leaderboard also. So really happy that worked out.
Okay. I also want to discuss another aspect. You're a seasoned Kaggler, but many beginners struggle with this thing of, should I need to do XYZ course before I can do Kaggle, before I can learn about transformers? What advice do you have for them? Because there's also this aspect of modeling very fast, which you can only learn on Kaggle. When should they jump on Kaggle? Should they first go back and do all of those courses, or should they jump on Kaggle right away?
For me, it worked out quite well to directly jump into a hard problem for yourself, because there you learn the most. And friends of mine who just joined Kaggle, I always advise to do so. So just pick something that you are interested in. And try with the hard things that make you feel uncomfortable a bit, not too much. You wouldn't start something where you need, like, I don't know, a high performance cluster to participate. Something that's doable, but you shouldn't have the ambition to perform like in the top region, but rather to do your best and to start with something complicated for you. And I also think it's really helpful to find teammates from who you can learn, and also from who you can learn efficiently. So it doesn't make sense to team up with a very experienced person with whom you can't keep up with, but ideally you would team with someone who's slightly either better, or he had a different strengths than you are, so you can learn from them.
Got it. In hindsight, or maybe if you could give any few examples, how has Kaggle impacted your professional life? Are you taking away any learnings that are helping with your off Kaggle data science work?
I think like 99% of my off-Kaggle data science comes from Kaggle, because I had no data science experience before Kaggle. So basically 99% of my of my experience comes from Kaggle knowledge.
This question of mine originates from the fact that now many people start to talk about Kaggle is not equal to data science, and no one of them is a Kaggler, so I'm trying to get the opinion of the best Kagglers against it.
Yeah, I think there's like, often people start with statistics, data science, analytics, and then come to Kaggle, but some directly jump into Kaggle from their physicists or worked in chemistry, often have like PhD, and over Kaggle they start to have contact with data science in general.
Sometimes constructions also.
yeah. It's you never know. There's one girl, she's like a linguist, so she studied linguistics and then was interested in doing NLP things, and then started to compete in an NLP competition. And she had all this domain knowledge from linguistics.
Yeah,
it was quite a fun experience for her to have like this contrast in what linguists think about how language should be processed, how language is set up basically, and then you have like this Kaggle guys who just throw transformers onto the stuff. And it just works really great. So
yeah. What best advice do you have for someone who's just starting out on Kaggle?
Yeah, as I mentioned, start with something difficult for yourself, and try to read everything you can get on the platform. So read all the discussion posts, read also kernel questions and posts. Try not to copy too much. So it doesn't make sense to just copy the best performing public kernel and then try to tweak a few hyperparameters and to improve that way, because I think the kernels which are public are already tuned in their hyperparameters so much that they are working quite well on the public leaderboard, which doesn't mean they will perform good on the private leaderboard, but rather start with your own ideas. And if you run out of ideas, try to peek in public kernels to get some more inspiration, but try not to copy too much. Rather take, I don't know, 2-3 days longer to implement your own thing than just like copy everything from a public one. It might be not as efficient for your first competition, but in the long run, it's way better to have come up with things by yourself.
I think that's also useful to beginners who struggle with starting with a blank notebook. That's where the copy forking works for. But if it becomes a habit, you can actually never start with a blank notebook and might not be able to tackle a real data science problem at work which you're aspiring for.
Yeah.
Now, speaking of work, coming to your new role, you just joined the Rapids team at NVIDIA. Can you tell us more about your work at Rapids and what tasks are you working on? Did they give access to you to a large number of GPUs? Is that your reason for joining?
No. Yeah, I'm really excited to have joined Rapids. They are building a team of Kaggle Grandmasters. And I guess all the team have the same role description or the same job. It has many facets, but the main role is to use Rapids in machine learning competitions, which is great for people who love to do machine learning competitions. And by doing so, the idea is to enhance Rapids and to create more functions within Rapids. So for those who don't know Rapids, it's a collection of Python packages with which you can compute directly on the GPU. So there's like a QML, which is like sklearn, but on GPU. There's QDF, which is like pandas, but on GPU. And the idea is to have the functionalities of those two packages, sklearn and pandas, but the speed of having GPUs at your service. And I think that will become more and more important also on Kaggle, because now as Kaggle moves towards inference to be done in kernels, it becomes really, really important to have efficient running code and to have fast running code.
Yeah.
So I think in the next competition where you need to do something with tabular data, Rapids will give a huge edge for those who can use it. Yeah, and our purpose is to use Rapids in these competitions and to on the one side act as a power user who heavily uses this framework to identify bugs which might be in there, but also give indication what features are missing, what you would need to add. There's a few people working on, especially on deep learning on tabular data. So as you mentioned, there's a lot of mistakes you can make with deep learning for tabular data, a lot of different pre-processing, post-processing. And they are enhancing the Rapids framework for also handling these things more efficiently. Because if you think about it, ideally, you would not only do the modeling on GPU, but also the pre-processing and the post-processing and have one workflow. So one example is loading a 1 gigabyte data frame to pandas takes 5 minutes. So it's really slow. Load and then you do something, you do some pre-processing, like, I don't know, label encoding, normalization or something, which also takes forever. And then at some point you have your model set up, and then you transfer everything to the GPU and then do your modeling. And the ideas from Rapids is you directly load your data into the GPU, which takes 20 seconds instead of 5 minutes. Then do the pre-processing there, which is also factor of 100 faster because you're directly on GPU. And then also do the modeling there. And you don't have this copying back and forth between CPU and GPU. So it's just like way faster and way more efficient as it compared to how people are doing data science nowadays. And I'm quite excited to play a big part in this in the future.
I'd also point the audience to another interview that I did with Evan Aldridge, where we discussed this in a much more depth. But I think the end vision with Rapids is if you could just replace import pandas as PD with import Rapids submodule as PD, all of the codes should be able to function with all of the sub functions of pandas and deliver the huge speedups that you mentioned.
Yeah, exactly. So the idea is to have the functionality of pandas and sklearn, but the speed of GPU, and then you can build an end-to-end pipeline with that.
Awesome. What's next for you? Will you continue to Kaggle, or will you focus more on work, or will you Kaggle from work?
I think it's the same thing now. So my job is basically doing machine learning competitions and using the Rapids framework for that. And right now I just entered one computer vision competition. And I'm really interested in improving the pre-processing and post-processing for computer vision. So there's a lot of things in pre-processing you can do, like augmentation and so on, which is currently done on CPU, which in my opinion doesn't make sense to do it not on a GPU. And there's also a lot of things you can do with respect to post-processing in computer vision. So I know that, for example, metric learning, where you try to find from a test image, you try to find a similar image from train and take the labels of that one. So you need to find similar images and so on. And this is normally a post-processing step that also happens on CPU nowadays. And it's also really, right now, really inefficient and slow. And it would be really awesome to also put that on GPU. So that's what I'm currently working on. So I think that's how it's meant to be. You compete in a competition, and you try to find out what's missing and where's room for improvement and where you can do more things on the GPU.
I'd also point the audience to another interview that I did with James Dallinger about the DALI library, where again a framework by NVIDIA which allows you to do image augmentations on the GPU with the same end goal that we're talking about.
Yeah, that's also on my to-do list. So I joined rather recently, and what to do is check out the DALI library and see if it already has everything I need, or if there's anything you would love to have for using it for competition.
Awesome. Now, before we end the call, what would be your best advice to someone who's just starting their machine learning journey?
Don't be scared, I would say, and jump right into it. Just try your first Kaggle competition, even if it seems very, very difficult. There's always people who answer questions in the forum. So if you have a question, if you have problems with your cross-validation, just put up a post, and normally people are really, really open and transparent in answering.
But also make sure that you do your homework before posting the question. Don't just ask all of the Google questions right there.
Yeah. There shouldn't be something that you can easily Google, and it shouldn't be something that already someone else answered the day before or something.
Awesome. Before we end the call, what would be the best platforms to follow you and follow your work? I'll have these linked in the description again for those of the audience who want to check it out.
There's a LinkedIn account, which is the Christof account. And then I have a Twitter account, which is purely from my data analysis, which is a pure Kaggle related. So I just post Kaggle related things there.
Okay, awesome. I'll have both of those linked in the description. Christof, thank you so much for joining me on the podcast, and thank you so much for all of your contributions to the Kaggle community.
Yeah, thank you too. I'm really, really proud that I was invited to your podcast.
It was really a privilege to have you on the show. Thanks so much.
Yeah, bye-bye.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.